This is Chemistry Week 3, and we're actually starting Module 3 this week. Hopefully everybody read the right place. I warned you guys last week to not, just keep going in the book, but to follow your syllabus. And so there's actually a very good reason for that. Chapter 2 is very difficult, and a lot of people, when they hit Chapter 2, they think the chemistry is so hard that if it's going to get that hard, they're just not going to be able to do it. So I want to go ahead and let you get your feet under you, and then we'll go back and do Module 2 later after you've done a lot of chemistry and you have some confidence and you know that you're able to do this. Hopefully everybody has already prayed. I have. And I've asked that God would be glorified in this time. Always remember to pray before you start this, and also pray before you study, and pray before you take your test. But don't just wait and pray just before you take your test, because then you didn't pray when you studied, and that's really important. So make sure you pray when you study, and you pray when you're doing your homework, and before class, which I have done for us. But I would like you to also. Okay, we're going to go over your test first. So the Module 1 test, please get that out. And let's go ahead and go over that together. The first question is, what are the meanings for the prefixes milli, centi, and kilo? For milli, it's 1/1000th. You could have written that 0.001. For centi, it's 1/100th, or you could have written that 0.01. And kilo is times 1,000, so you could have just written 1,000. That would have been fine. This next question is, which is heavier, a 0.3 gram rock or a 30 milligram rock? So we have a 0.3 gram or a 30, I'm just looking for my significant figures, milligram. I'm going to go ahead and take this number to grams. You could have done it the other way. It doesn't matter. This is the big one. So this is actually 3 decimal places over, 0.0300 grams. Now, is it obvious which one's bigger? And isn't that the question he asked? He asked which one is heavier. And so the 0.3 grams is heavier than 0.03 grams. That's much closer than what was in your homework. So it was very important that you actually did the math. Once again, you could have converted the grams to milligrams. You'd still seen the correct answer. So it's just important that you actually did the conversion so that you saw which one was the heavier of the two. The following numbers are the result of several measurements of a football field, which is supposed to be 100 yards long. Which of these numbers represents the most precise measurement? Remember, the most precise would have the most digits. And so if we look here, C has the most digits, particularly to the right of the decimal. So C would be the most precise answer. Whereas the next question is, which is the most accurate? And the most accurate answer would be B, because that is actually the closest to 100, isn't it? Okay, so C and B would be your answers for number 3. Number 4, if we observe a fishing bobber floating on the surface of the water, what can we conclude about the density of the bobber compared to the density of the water? Well, obviously the bobber is less dense than the water, and that's why it would float on top. Number 5, what is the volume of the liquid in the following graduated cylinder? Okay, so it's showing you here that the graduations, if you count between 20 and 30, there are 1, 2, 3, 4. So each of the lines represents 2 mils. First, you had to figure that out. Each line represents 2 mils. So now that knowing that, you can see that it's around 23 mils, around 23. And it's the precision of the instrument is to the ones place, so we're going to go out 1 past that. We're going to estimate 1 past that. So your answer could have been, well, let's see, Jay Wiles actually says anything between 22.6, or he gives you all the way up to 23.2. I would dare to say 22 and point anything to 23 point anything would be an acceptable answer, but what am I missing here? That's right, got to have milliliters behind it. If you don't have milliliters, take off 1 point. If you only have 22 or 23, take off 1 point because you missed your significant figures. Okay? Now, this is very important. Whatever you got for this answer, you have to use in the next answer. So I'm only going to show you how to do the work for the next answer, and then you're going to have to figure out what your answer should be so that you get proper credit. I'm going to go ahead and personally, I would call this, personally I'd call it 22.8. So that's just how I read it. So I'm going to call this 22.8 mils. Okay, so for the next problem, it says if the mass of the liquid in number 5, so this is the volume, if the mass is 32.13 grams, he wants to know what's the destiny. You like that? It's density, not its destiny. And so this is our density. Remember that rho equals mass over volume. And so we're going to plug that in up here. Rho equals mass 32.13 grams over whatever number you got in number 5. Even if you got it wrong and you put 20 or you put 30, whatever number you had there, you were supposed to plug in here. So I'm going to go ahead and put my number in here. And then you were to go ahead and use your calculator. And your answer should be in 3 significant figures. So this would be my answer in 3 significant figures. One way or another, as long as you, on this problem, wrote out your given and your get to, wrote out that you plugged in your mass, which he gave you, so this should be up top, divided by whatever you got in problem 5, and then your answer should be in 3 significant figures because, well, if you got 2 significant figures for number 5, then your answer should be in 2 significant figures. So it depends on what you did in number 5. And then grams per mil. And you have to have this there. If you don't have your dimensions, take off 1 point. If your number of significant figures is wrong for what you put here, if you had 2 here, you should have 2 significant figures. If you have 3 here, you should have 3 significant figures. Take off another point. Don't take off if you got this number wrong on number 5, because I just want to know that you know how to do density here. Okay? And I'll tell you at the end how much each of them are actually worth. Okay, number 7, I'm going to erase my board. Number 7 says how many centimeters are in 16.2 meters. So 16.2 meters, we want to know how many centimeters. So I'm going to times line meters, centimeters. He's the big boy. This one gets 100, so that's going to give me centimeters, 1,620 centimeters. And that is the right number of significant figures. You could have written this way. Whoops. Yep, I was right. You could have written this way. That could have, either way would have been a correct answer, just so you know. Okay. Let's see. On number 8. On number 8, if an object has a mass of 345.6 milligrams, he wants to know how many grams is that. Times line. Milligrams goes on the bottom, grams on the top. This one's the bigger one. And so we're going to divide by 1,000. So this is going to be 0.3456 grams, because that'll cancel. And then if you wanted to express this in scientific notation, which you are welcome either way, it would be times 10 to the negative first grams. Okay, so it could be expressed either way would be fine. You have to have the right number of significant figures. If you don't, take off 1 point. If you don't have your grams written there, take off 1 point. That would be the case in each of these cases. Okay, number 9. If a football field is 100 yards long, how many miles long is it? Okay, so we have, good, I didn't skip one. I'm bad about skipping them. So we have 100 yards. Now we want to know how many miles that is. So I'm going to go times line. He doesn't tell us how many yards there are in a mile, but he tells us how many feet there are in a mile. So I'm going to go from yards to feet. And then I'm going to go times line. Feet go down here, and miles go up here because these are the numbers I know. So I know that in 1 yard there's 3 feet, and I know that in 1 mile, and he gives this to us, there's 5.6 I'm going to just write it out. But I can't, because he gives it to us that way to tell us there's 4 significant figures, so I have to write it this way. Sorry, guys. There we go. Okay. Oh, these single digits, I should have told you this before, and I'm sorry, it was in the textbook though. These single digits have an infinite number of significant figures, so you don't limit the answer by these numbers. It would be limited by the actual measured numbers. Okay, so this would be the work we have to do, so we're going to go ahead and take your calculator, and you're going to go, that's going to be 300 divided by 5280 equals, and the answer I get in my calculator is 0.0, how many significant figures? 4 and 4. So I can have 4 significant figures. 4, 6, 8. Now this is going to 5 significant figures because look what you have to do here. You have to round this number up. So the answer would actually round up to a 2 here. And then you could have either written it this way, miles, or did he ask for it in? No, he didn't ask for it this way, but you could have written it this way. Either way, you have to have miles. This would be your number. If you didn't round up, take 1 point off. If you have the wrong number of significant figures, take 1 point off. If you don't have miles, take 1 point off. That's about the best I can help you with. If you missed the whole thing, put an X in front of the whole thing and I'll tell you how much each of the problems are worth in a minute because he's got them calculated here. Okay, number 10. The density of gold is 19.3 grams per mil. A miner finds a gold nugget whose volume is 34.2 mils and whose mass is 661 grams. Is it really gold? It's a practical question, right? Okay, so we have the volume is 34.2 mils. And we have the mass as 661 grams. Now we want to know what the density is, mass over volume. And he gives us the density in grams per mil. Well, that's convenient because this is already in grams per mil, isn't it? So let's just go ahead and plug in. So we have 661 grams per 34.2 mils. And so 661 divided by 34.2 gives me 19.3 grams per mil. Is it gold? Yes, it's gold. So that would be your answer on that one. Hopefully none of you just guessed. Although guessing would have been better than leaving it blank. Don't leave anything blank. Always try. Okay, number 11. A fisherman wants to determine the volume of his lead sinker. If lead's density is 11.4 grams per cc, and the sinker has a mass of 0.123 kilograms, what is the volume of the sinker? Okay, right away I'm going to figure out my equation. So that's going to make volume equal mass over rho. I can see that I'm going to have to convert kilograms to grams. So I'm going to go ahead and take care of that. So that's going to give me 123 grams. Now I can go ahead, whoops, I'm going to write this, V equals M over rho. So the mass over the density should leave me the volume in mils. So get your calculator. Yeah, and he doesn't tell you what volume he wants it in, so you can leave it in cc's. And so it's 123 divided by 11.4. 3 significant figures. What's in my calculator is this. So you need to round this up. So 3 significant figures would be this, cc's. That should be what your answer is. You could have put it in scientific notation if you wanted to. Let me just check because you know what I should do. Let me just check what he says. That's probably the safest way, huh? And we're on number 11. 11, yep. He writes it just like that. You could have written it in a scientific notation if you wanted to. That's always going to be okay. Okay. Let's go to the next one. Convert this number to scientific notation. So he gives us this number, 3. Can you? Okay. Remember, the decimal is actually here. So 1, 2, 3. So we're going to write that as 3.478 times 10 to the third. That should be your answer. The next one, you're going to convert this number into decimal. So you're converting it out of scientific notation. Okay, this time it's going to go back 4. So when you do that, you're going to have 1, 2, 3, 4. So it would be that number. Okay. The next one is a hard one. So let's look at that one. Next one, he says the volume of a sphere is given in the equation. And so he gives us this equation. The volume of a sphere is 4/3 pi r cubed. And then he gives us what pi is. And the radius, the r is the radius of the sphere. If the sphere's radius, so he tells us r equals 3.1 meters, he wants to know what is the volume in liters. So this is the information he gives us. Now, remember that your bridge between meters and liters is that 1 milliliter equals 1 centimeter cubed. Okay, first though, let's go ahead and plug in because that's the easiest thing we can do, right? So we'll go ahead and we go, this equals 4/3. He gives you in here what pi is. It may be in your calculator, it's in most of them. But just in case, we're going to go ahead and write it here the way he's done it because of the significant figures. Okay, then we're going to take r and we're going to cube it, 3.1 meters, and this whole thing is cubed. Okay, so far, if you have that much written down, I'll give you some credit. So here we go, 3.1 times 3.1 times 3.1 equals, okay, or you may be sharper on your calculator, whatever it takes, times 3.1416 equals times 4 equals divided by 3 equals. I have 5 significant figures here, but I only have 2 here, so my answer has to be in 2 significant figures. And the answer that's actually in my calculator, I'm going to write it here for you, is 124.7885. Okay, I can only have 2 significant figures. So this is actually going to round this up to 125, isn't it? So how do I express 125 in 2 significant figures? I can either write it as 130, or you can write it as 1.3 times 10 to the second. Your choice. Either way, it's 2 significant figures. And then this has to be meters cubed. Now, he's broken this problem actually down into 3 parts. And if you have that part, if you have that part right, oh, see, he didn't round it. I did. Shame on me. He rounds it to a 2. Okay, because the next number was a 4, and that's what he went with. So let's go with that. Okay, if you got this far, or if you put 130 meters cubed, you got 1/3 of this, because this problem has 3 parts. So you got this part right, you're a third of the way home. Now the next thing is that he wanted to know you knew how to make your bridge, because now we have meters cubed. I'm going to erase this so I have room, and we'll put this at the bottom. We're trying to get to liters, right? I have meters cubed. You're supposed to know your bridge between meters and liters is centimeters cubed and milliliters. So then you're going to do the conversion. You're going to do meters to centimeters, right? Because you're trying to get to centimeters. And you know that one of these is 100 of these, but now we need them cubed. So we're going to cube it. So this is going to be this. This is going to be this. Okay? And then you could have done this step by step. I think he actually does it step by step. So that would give you 1.2 times 10 to the 8th centimeters cubed. That's the second step. If you have that right, you've gotten 2/3 of the problem correct. Okay, then what do? Now we're going to take this, and if you're this far, whatever number you got here, if you took that number and converted it from centimeters cubed to milliliters, which is a 1-to-1, right? So in other words, for space purposes, because I have a little board, I'm going to go ahead and just write this now as milliliters. And you could have done that too, because you know that. Then you just take this and go from milliliters to liters, 1, 10 to the 3rd, so it's going to be 10 to the 5th, that's a 5, liters. And that is going to be the volume in liters. There are 3 parts to this problem, and each of the 3 parts are worth, hang on, divided by 21. Each of the 3 parts are worth like 4 points. So if you got this right and these wrong, it took 8 points off your test. Actually 9, but we'll be nice. So each of these are worth 4 points. So together, the whole problem is worth 12 points. If you didn't do right any part of it, then yeah. Let me just say this right now. If you get less than an 80 on any of these chemistry tests, or let's say you really want an A in this course, what you need to do is put the test away, and you need to go back, and you need to restudy the chapter, and then take the test again. Because the idea is to learn it. And so, learn it. Do what it takes to learn it. And go back and perfect practice makes perfect. So you need to practice, practice, practice. Last problem. The mass of an object is measured on Earth, and it's also on the moon. How do the two measured masses compare? The answer should be there exactly the same, because remember, the mass doesn't change from here to the moon. It's your weight that changes, because weight is how the gravity pulls on the mass. So the answer is they're the same. There should be no differences. Okay, now, like I said, on your test, Jay Wiles has made it 21 possible points, which basically makes everything worth 4.5 points. So on number 1, he counted the answers to each of those prefixes as 4.5 points. Number 2, the whole thing is worth 4.5 points. Number 3, just make each of the things worth 2.5 points, each answer. Number 4, it's worth 4.5. 5 is worth 4.5. 6 is worth 4.5. 7, 8 are worth 4.5, both of those. 9 is worth, there's 2 movements there, 2 halves. So as long as you got, he says as long as you could get yards to feet, that's worth 4.5 points. And then if you got feet to miles, it's worth 4.5 points. On number 10, it's 4.5 points. 11 is worth 9. So if you got it to from kilograms to grams, it's worth 4.5 points. And then if you found the actual volume, it's worth 4.5 points. Then 12 and 13 are both worth 4.5 points. 14, I already told you, each of those movements is worth 4.5 points. And 15 is worth 4.5 points. And don't add them up and see what your grade is, because I'm cutting you some slack. So whatever you miss, subtract it from 100, and that would be your grade. All right, let's put that away and open your books up to Chapter 3 on page 67, please. Okay, on page 67, we're starting to look at atoms and molecules. I bet you said, wow, real chemistry. Whoa! Okay, and so it's all real chemistry, but some of it's more chemistry-like than others. So as we go through this, we're actually looking at a little bit of history and how matter is composed and how they figured it out. He tells us that originally the Greek philosophers thought that matter was continuous, so that it was just, no matter how many times you cut something, you would just get more of it. It just cut into smaller and smaller units. And then Democritus, who lived about 4 centuries before the time of Christ, was on the beach, and he noticed at a distance the beach looked like a big golden bar of one thing, but he also knew that when he got closer to the beach, it was made up of a lot of little particles, and he started wondering, wow, wonder if the ocean is actually made up of a bunch of little particles that when they come together, they look like they're all one big piece. So instead of the continuous theory of matter, he was the one to introduce the discontinuous theory of matter, which is that idea that matter is made up of smaller parts. And we know now that he was correct, because water is actually made up of a bunch of water molecules. So that's where that started. And then he goes on to, on page 70, to talk about the law of conservation of mass. And in the late 1700s, Lavoisier, which is considered the father of modern chemistry, put forth what is now considered a scientific law. A scientific law is just a very well-tested scientific theory that's never been seen to be wrong. It could be wrong, but I kind of doubt this one's wrong. I think the law of conservation of mass fits what the scripture says, because God did his creation in the 6 days during the creation week. He rested on the seventh day, and nothing is being made since then. And so what this law says is that matter is neither created nor destroyed. It can only change form. You notice I say it a little differently. That's how I have it memorized from when I was in school. This is one to memorize. Matter is neither created nor destroyed. It can only change form, because you're just going to need to know this one. Okay, and the example he gives is a good one. When you burn a piece of wood, it looks like the wood disappears. So wait a minute, what about, that seems to be being destroyed. But it's actually the wood and the oxygen that goes into it to burn the wood is actually turning into ash, carbon dioxide, and water vapor. And so it's not disappearing. If you actually measured the oxygen in the wood that went in and the ash, the carbon dioxide, and the water vapor that came out, you would find that you have the exact same mass as what went in. And so we have this experiment to do. On page 71, we have experiment 3.1 called conservation of mass. And we'll do this one together. You're welcome to do it at home if you would like. I've already cooked the cabbage juice. I even do that for my classes in class, because I don't bother doing that, in class. We can do that at home. And then I eat the cabbage because I like veggies. But anyway, so you can do that. A little butter and garlic salt's really good. So as we go on, what we're going to do here is, if you look at the experiment, the first thing he tells us to do after starting the cabbage is on number 4. He tells us that we are to measure the mass of our beaker, because this experiment is all about mass. So we're going to write these numbers up on the board. And so let's get started. Okay, the first thing we're told to do is to measure the mass of our beaker. And in this case, okay, so I'm going to go ahead and we're going to measure the mass of our small beaker. Make sure your scale is zeroed, and then we're going to go ahead and measure the mass. My beaker weighs about 65 grams. And so I'm going to put here, and remember this is to the tens place, so I'm estimating one digit out, so 65 grams would be the mass of my beaker. Okay. And that was on number 4. Number 5 says add approximately 60 mils of vinegar to the beaker. And he says here we're doing a qualitative measurement. Now, remember, he says here that a qualitative measurement doesn't have to be real specific, whereas a quantitative measurement has to be as exact as possible. We're doing qualitative. Then on number 6, he says to put on gloves. So I'm going to oblige him, and I'm going to put on my plastic gloves. And then I think I've skipped something though, haven't I? I forgot to add my 60 mils to my little beaker. So let's add the 60 mils to the little beaker. Here's 60 mils of vinegar. Okay. He doesn't tell me to weigh it again. He just tells me to add it in there. All right, got my gloves on. Measure out 1 teaspoon of lye, put it on a watch glass. And be careful with the lye. If you do this at home, be very careful with it, because it really will tear you up. Okay, then he says to carefully pour about 50 mils. Okay, we already have this is the red cabbage juice. And so he says that once the solution is cool enough to pick up, you're going to pour 10 mils of the solution into the 100 mil beaker. So there's already 60 mils in here, so I'm going to pour it up to the 70 mil mark. And your beaker is also calibrated. Don't you love the color changes? That's because it's a pH indicator, and the pH changes. It's what's in leaves on trees during the fall. If you took his biology course, you did an experiment with that before. Okay, then it says place the stir rod in the beaker. So we're going to put our stir rod into our beaker. Okay. It would be better if my mass scale had one of the little square things like his does, but I don't. So we're just going to do the best we can. Then we're going to place the watch glass on top of the beaker so that it covers the mouth. So here's the watch glass with our red devil lye, and we're going to put that on top of here. I'm going to try at least. Okay. And so we have that all together, and then he says to measure the mass of the total assembly. So the total assembly is, it looks like 175. So we're going to say mass total equals 175 grams. Measured the 175, after you've measured this whole apparatus, it says to dump the lye into the vinegar. So we're going to dump the lye. Oh, you notice he says to wear goggles. I have my goggles here, so just because he told me to, I'm not always going to wear my goggles, but this time I'm going to be good. I'm going to wear my goggles. Okay, dump the lye into the vinegar. Notice that the color was pink before. Now, it says that once you've done that, we should stir this and watch the lye disappear. What do you see happening here? You see a color change, don't you? That's because we actually have a chemical reaction going on here, and it is no longer... The vinegar is an acid, and we no longer have an acid here. The lye is a very powerful base, and it changed what's in there to a base. I'm going to put the watch glass back on. So all the lye is actually gone now. We have a chemical reaction. I guess I have a little in the bottom there, don't I? But the point is, all the lye, I had more lye than it could take. But anyway, all the lye has... it has reacted what it can, and we've got a new molecule in there, a new solution, because of the chemical reaction. So now, after we've done that, you're supposed to feel it and feel that it's warm, which it is, because the reaction not only has changed the color, but the reaction has occurred, and it's what's called an exothermic reaction. It's given off energy. And then we're supposed to read the mass of the entire assembly again. That's number 21. And if you look, it's exactly the same as it was before. There's no change in the mass. And then we're supposed to clean up. I like to call that the Barney step. Go ahead and bring it up. And so you go ahead and you clean up your mess.